Let's find the following integral. Here we have a fraction that contains the cosine of x. Most of the time it's very requiring to find a primitive of this kind. We need to do some work to find the primitive of a fraction that contains the cosine or the sine. But in general, the key to solving this problem is to use a change of variable that's very famous and that everyone needs to know. So we change with a t, in fact, equals tangent of x over 2. Okay? This half angle for the tangent would definitely help us solve the cosine and the sine. Okay? So the first thing that we need to know is that in doing this change of variable, we get the cosine of x as 1 minus t squared over 1 plus t squared. I have proved this result in one of the videos. And doing this, we get the cosine. Now we need to have dx. To have dx, we differentiate t. We get dt is 1/2 1 plus tangent x over 2 squared, which is t squared, dx. Therefore, dx is 2 1 over 1 plus t squared dt. Okay, now we have all we need to solve this integral. Okay, so here we have 1 over 5 plus 3. The cosine is 1 minus t squared over 1 plus t squared. And dx is 2 over 1 plus t squared dt. Okay, let's move these two to the front. So we have 2 1 over 5 times 1 plus t squared plus 3 times 1 minus t squared. And we simplify by 1 over t squared. Okay, and that's it. Therefore, we have this integral as 2. Here, if we simplify, we get 1 over 5t squared minus, that means 2t squared plus 8. And with these two, we get just 1 over t squared plus 4 dt. Here, we recognize that we can have a primitive of the arctangent, but we need to get rid of this 4. To get rid of the 4, we just factor out by the 4, and we have 1 over t squared, t over 2 squared plus 1. And therefore, to have a primitive, we need to multiply by 2 and divide by 2. That means we need to have 1/2 1 over 2 here, and we multiply by 2. This gives us 2 here. Okay, and now we see that this is just 1/2 the arctangent of t over 2. Let's forget about the constant for now. Okay, so now we switch back to x. Okay, we have 1/2 arctangent of t, which is tangent x over 2, and we have these two here. And let's add c, a constant now. Therefore, this is our integral. Okay, so this is this integral 1 over 5 plus 3 cosine x dx. Okay, so we needed this change of variable to make it through these steps here. Okay, here we needed this 1/2 because one here, when we do the chain rule, we're gonna have 1/2, and we needed 1/2, and I had to divide and multiply by 2, and I used the other 2 to get rid of this this 4 that I had here. Okay, because I needed to get the 4 here, so I changed it to get the 1/2. And I think that's it. This is all the steps. The key idea here is that this change of variable here would definitely help in dealing with this kind of fractions that contain either the sine or the cosine or a combination of them. Okay? So you need to have this one in your mind. You may need it later. Thank you.